Okay, good evening, folks. As you can see, I'm still in a hotel room in India. It's been a busy day, and I've got a couple of things on that board behind me, which I'll discuss later. Now, it seems to me there's a guy on a channel called Sleeping Warrior, who you all know about, I presume. And every time he has a brain fart, he does a video trying to debunk science. So for some reason or other, even without a science education, well, obviously, he makes out that he's better than Newton, better than Einstein, better than anybody, and these people are all wrong and he's right. Okay, all right, so we're going to have a look at a few things that he said and deal with them. Okay, well, the first thing, he starts off with some with a claim that the Earth could be a globe or it could be something else, but it's probably flat. So, and what he's saying is that we should be honest with ourselves and take the middle ground and accept that it could be a globe or it could be something else, or even flat. Well, no. It's only one thing, Mr. Riley. It's demonstrably a sphere. Now, just as a matter of example, just this last Wednesday, we launched a rocket from over here with 30 satellites on board. One of them is the Cartosat 3. The others were some nano satellites, experimental things from various countries, including the United States. Now, Cartosat 3 is a polar satellite, so running in a sun stationary format, or sun stationary orbit. Now, what that means, Mr. Riley, is that this satellite goes around the Earth from pole to pole, just a few degrees off. And while it's doing that, the Earth is spinning beneath it. And the purpose is for the satellite to be able to photograph the Earth, every square inch of the Earth, in 12 hours. That's how it works. This, Mr. Riley, is undeniable, and this could not work with any other configuration than the Earth is a sphere. So your assertion that it could be this or it could be that is nonsense. Okay. The next thing he did was declare that the atmosphere is a fraud. Well, you are wrong. First of all, what are you saying here? Jacques Charles is a fraud. Robert Boyle is a fraud. Guy Lussac is a fraud. Robert Dalton is a fraud. All these people have conspired to fool the public. That's your contention. Well, if you really think that you're a moron. These are some of the finest people in science. But for them, there is so much that we wouldn't know today. And one of those things is how the atmosphere works. Okay, let's have a look at some specifics. So Mr. Riley brings up the ideal gas equation, PV equals nRT, and decides to tell us that this is that PV equals nRT is just some sort of superfluous game, model that we try to look at how a gas behaves with. Well, Mr. Riley, PV equals nRT is a very, very important equation, and every part of it is important. In fact, we use it for extremely precise calculations and measurements. All right, so what does he say about it? First of all, he seems to be confused. He's confused about the difference between what's an ideal gas and what we call a real gas. So, what is the difference? First of all, in the ideal gas equation, we're not particularly concerned about the size or the volume of a particular atom or a particular model. These things are so tiny that they are insignificant in the space that's taken up. For instance, air is 29 grams per mole. And this at 20 degrees or 293 degrees Kelvin would occupy 22.45 litres. So 25 grams of gas would be pretty insignificant in that size of volume. Do you get it? Now, real is the alternative. This is where we take into account the actual particle volume. Now, as far as atmosphere is concerned, there really isn't any significant difference that we would have to worry about. Okay, but one of the things that's very obvious, Mr. Riley, in your little discussion about PV equals nRT is that you ignore N because you don't know what moles are, and you ignore R because you don't have a clue what the gas constant is. Well, these are important variables in this equation, so they do matter. Okay. All right, so the gist of what Mr. Riley is trying to push here is that volume is that the volume is the entire universe. So he thought he was really clever by challenging us to multiply by infinity. Well, Mr. Riley, that's not that clever. You see, volume means the atmosphere. That's the gas encapsulated by gravity. The stuff that's around the Earth. Now, sure, we do lose some of it, but that is very, very insignificant compared to what's there. So the volume means the entirety of the atmosphere around the Earth, not the universe. So your argument is meaningless. Okay, so let's have a look at the board behind me. Let's discuss some of this. All right, so here we have the equation. PV equals nRT. P is the pressure. Yep, you did work that out. V is the volume. You got that too. Even though you didn't understand that it means the volume held in by gravity and not the entire universe. T is the temperature. You got that. That's in Kelvin. R is the gas constant. That you didn't have a clue about. N is the number of moles. You didn't have a clue about that either, did you? Now, if we have a look at this formula, where moles is equal to PV over RT. Now, if we want to use this formula for any general gas, then we would use R, the gas constant, equals to 8.31. But if we wanted to be specific for a particular gas, then we'd use the gas constant attributed to that particular gas. So you can see it is important. Now, volume of the atmosphere doesn't change much. So yes, as I said, we would lose some, but that is so insignificant it doesn't matter compared to the rest of it. And R is the gas constant. So these two, V and R, are constants. So effectively, we can take them out of the equation. And what do we have left? That moles, the number of moles, that's the amount of the gas there in the atmosphere, is proportional to, directly proportional to the pressure and inversely proportional to the temperature. This is exactly what we observed, Mr. Riley. This is how the atmosphere works. As we go up in altitude, the temperature gets less and less. And the pressure gets less and less. That's because there are less and less molecules. Temperature is less and less because there's less and less molecules to collide with each other. Pressure is less and less because there's less molecules the higher up you go. So therefore there's less molecules weighing down, if you like. Okay. And again, this matches our observation exactly. Now, let's see what else Mr. Riley had to say. Oh yes, his little tirade on force and mass and little g, gravity. Well, it seems that Mr. Riley is asserting that mg, that's mass times gravity, is not a force because g is not a force and m is not a force. Well, let me fill you in on this. Together, they are a force. That's how it works. This is consistent with Newton's observations, and this is also consistent with Einstein's observations. So, in terms of Einstein, mass bends space-time. Mass is required for space-time to bend. And because space-time is bent, other things in the vicinity are affected by it and drawn into the swell. That's how it works. That's how gravity happens. So this drawing of the object into the well of another, for all the world, looks to us like two objects are attracted to each other. That causes them to have a force together. F does equal to mg. Okay, where g is the acceleration due to gravity. Okay. All right. What else does he say? All right. He goes on to do a quick demonstration with using Dalton's law, which is, in his mind, he thinks that he's demonstrating that that the gas will move from a low pressure area to a high pressure area, forgetting that, or perhaps he's just confused. Maybe you're just confused, Mr. Riley. Atmospheric pressure is not the same as gas pressure in a container. Okay, now, one last thing I'd like to say about this. Here he is calling these people frauds and then citing their work. How does that make sense even to you? Now, my advice, stick to what you know. Science is not for you, obviously. Okay. All right, folks, I think that's enough. If you like my video, then please just press the subscribe button, and I'll keep doing them. Thanks very much. Good night.